as a scientist, I think it's really a matter of intent. Reproductive cloning, to my mind, is cloning with the purpose of producing another human being. Therapeutic cloning, or as I call it, nuclear transplantation, is the notion of creating a group of cells which are able to assist dying or very sick tissue to regenerate.
Therapeutic cloning is when the embryo is a few days old. The cells become pluripotent. These cells are then able to differentiate to any one of the 220 different cell types. During this stage, the nucleus is changed. The cells grow into the cell type you changed the nucleus to. For example, if you put the nucleus from a skin cell into the embryonic stem cells, then it will turn into a skin cell. With this technology, organs can be grown to save lives and replace dysfunctional cells.
The cloned embryos were used as a source of stem cells, which can make new heart muscle, bone, brain tissue, or any other type of cell in the body. Being able to create new tissue might be able to heal the damage caused by a heart attack or repair a severed spinal cord.
Cloning, as it's most customarily practiced at the present, involves the transfer of nuclei from cells and transferring those cells into eggs where the nucleus has been removed, and then the nucleus from the animal to be cloned is put in its place. If it's a mammal, those new embryos then have to be transferred into recipient females for them to carry on to term.
Dolly was the first cloned animal. There have been thousands of cloned animals, and it is a fact that cloning doesn't work very well in animals. About 30 to 40%, this is the fact, of the animals have serious health problems. This is clearly not a technology that should be used on human beings.
I'm Dwayne Kramer. I'm a professor at Texas A&M University. Been working in the area of embryo transfer, cloning, and genetic engineering. I hope that there will be continued research to make it more dependable. At present, about 25% of offspring have some type of abnormality. They're developmental abnormalities. They're not mutations. They don't get passed on to the next generation, but they need special care.
The truth is that cloning is highly experimental and very problematic, and most of the time it doesn't work. Only a few clones have actually been born successfully, and of the ones that have been, a good percentage actually end up dying within the first 6 months because they have some sort of complication, health abnormality, a physical deformity, something like that. You talk about using a very large number of animals to even try to produce just one clone.
NPR reported that SBRF was charging $100,000 to clone a person's dog in 2015. Biogen has slashed that price in half. They charge $50,000 to clone a dog and $25,000 to clone a cat. But how much would it cost to clone a human? Doing the same work in humans, he estimates, could cost about $2 million. Scientists will almost certainly use fewer eggs if therapeutic cloning is used on people. But even if it requires a mere 100 eggs taken from 10 donors, the simple cost of paying the donors could easily reach $50,000.
So what about embryonic stem cells?
this is where the ethical controversy comes, and it becomes because they come from embryos. They come from the inner cell mass. So embryonic stem cells actually have the potential to teach us a lot about body's way that the body uses stem cells. And so clearly there's a role, but as we just said, may not be that the controversy needs to be where it's at. So do stem cells work? There's three parts to this question. The first is, of course they work. That's how we're here. When you cut your skin, it heals. Every week you turn around your platelets. You have brand new platelets every 7 days. If I take out half of your liver will grow back. And not only will it grow back, it'll stop growing, which again shows you the complexity of the process. The ability not only to grow new cells, but to control that growth is a very important process. So what we're trying to do with stem cell therapy, our goal is to enhance the body's natural process of regeneration. That's what we're trying to do. So how are we doing? Well, first of all, we know that stem cells work in animal models. Clear cut. We know that we can, multiple different stem cells, multiple different models, we can grow new blood vessels. We can grow new heart muscle. So we know that it works. But what about in patients? Are they effective in patients? We're going to come back to that in a few minutes. So how do stem cells work? This is another thing that's more complex, and we're learning more about it all the time. In the natural process, stem cells become the cells they're supposed to be. Stem cells for red blood cells become red blood cells. Stem cells in the muscle become muscle.